So here we are at the hood. It's been in the dark most of overnight from last night. So here is our tray of slides. Notice how I used one of the metal trays. Tried to make sure it was in the dark. And there they are, glued all the way around the edges. That nail polish is completely dry, and we should have multiple tissue sections still here in the middle. You can see we got 3 good ones right along here that we can look for as we go put these on the microscope, the Confocal Microscope room 220 in Peterson Hall. Okay, we're in the Confocal Microscope room. This is our confocal. It is an Olympus microscope, and Leeds is a distributor that sells the Olympus products. And so they gave us this dust cover. Why do you always find dust covers on microscopes? Well, if dust was to fall into the works here, right, that dust could get in the way of all the light that we're so dependent on. And so we always cover a microscope. Look at the ceiling. These tiles on our ceiling are actually different than every other tile in the building. This is the only room that has special tiles that produce virtually no dust. And so that is another thing that can help us keep this sort of as a clean room to help make sure that our microscope works well. Now, if you just pan around here, we've got a large screen TV, so that if there are multiple students in the room who want to see what is on the microscope, we can use this. Here's where I'll do most of my work at this computer right here. It's hooked up to a computer right here, and this is all what is going to control the epifluorescence that I lectured on yesterday in class. The epifluorescence. All over here, these are the power supplies. I mentioned the big black box. The lasers are in here. Okay? The lasers run into the confocal unit, and that is displayed on these other 2 screens. So yes, we have 4 screens to look at the results of this one microscope. These 2 screens are run by this computer. And these boxes here, the white boxes, are for control of the microscope. So we almost never have to do any touching of the microscope because it's going to be computer controlled by one or the other computers. So in order to start here, what I'm going to do is I'm going to make sure by unplugging this. Oh, somebody screwed it in tight there. This is the connection to the computer. Black cord, I'll call this a tan cord. The tan cord actually goes behind the microscope and attaches right over here on the back of this microscope, or this computer. So I'm going to start with the epifluorescence computer and make sure that these can talk to each other. This is our main power. So first thing to turn on, main power. Second thing, we'll turn on the UCB. Stands for Universal Control Box. The microscope now has electricity running to it because of the main power. Now we're going to take control of the machine, of the microscope itself. Focusing on here, let's look at some of these things that started glowing here. RMT, ERR, NP, MU, RSHT, Z, AF, okay? NP is the nose piece. The nose piece is, if we focus down in here, this region where the objective lenses of the microscope are. 4x, 10x, 20x, 40x, 60x, and 100x lenses. That's the nose piece. The universal control box has detected that it has control over the nose piece. It can rotate it for us. We do not have to touch it to rotate it. MU, RSHT, and Z are other aspects of the microscope that the computers can control. So what else do we need in order to be able to see our tissue sections here on the microscope? Well, of course, we need a light source. So let's turn on our X-Sight. I believe when I gave the lecture, I talked about our X-Sight 120. 120? No, what was the number? Anyways, This is the same brand. We recently got an upgrade to our light source for the epifluorescence light. So this is the Excite Mini Plus. So I'll turn that power on to the light source. Come on in here, and here is the place where the light is focused, coming out of this box and into a fiber optic cable, which I'll lift up at the back. This is the fiber optic cable. That light beams are being shot down, and they come around and enter right here. These visible epifluorescent lights do not do anything confocal. They just hit a mirror here and get shown right down onto our sections. So here's our microscope stage, and I've got a microscope slide here. Let's see, can I put this in front of something whitish? Yes. Developmental biology students, this is what cat ovary looks like. There is one ovary, two ovaries, and some of the connective tissue are the horizontal lines there. I chose this tissue and put a bunch of orange tape on it because the red is so easy to see. Whenever we sit down at any kind of microscope, you always put the slide on at the lowest objective lens, the lowest magnification power. So I'm going to pull up the chair here and sit down at our microscope, and I'm going to look and see. Yes, we're at the 4x objective lens. There's a lot of room for me to put this in there without scratching the $1,000 objective lens, right? Each of these is thousands of dollars. Very expensive glass in there that focuses light beautifully without any imperfections in the glass. So I can then move the stage around. Here I'm moving it back and forth towards me, and now I'm moving it side to side, and I'm going to center that reddish tissue right over the source of light. I have turned on a light supply, but I'm not really sure how much light is coming through there. So I'm going to use my hand as a little detector here. I'm going to put it down here and see if there is any shining light coming up from the bottom. I really don't see light coming out of here. So what we're going to do is, instead of messing with all the buttons on the microscope itself, because we have our tissue in place, let's go to the epifluorescent computer control, and let's use the computer to control turning on and turning off lights on the microscope.